Alright, so what I'm doing, I am prototyping a dual tracking power supply, and what that is a power supply that will have a positive rail and a negative rail, and the tracking part is when you adjust the output, both the negative and the positive will track each other. They'll be the same. So, alright, so let's explain our circuit here. At the top here, that is a lm317 positive linear adjustable voltage regulator. At the bottom is a lm337, a linear negative adjustable regulator. So they're kind of about the same series, but alright, and then I have a mains transformer set up for a center tap there. So the ground is that center tap wire right where that black wire is there. And then our taps go to a full bridge rectifier, supplying our positive and negative rails. But anyway, so I have a dual ganged potentiometer there. So what that is, that's just two potentiometers set up to one to where you can get a single adjust. And what I have one gang going to one regulator and the other going to another. So the idea there is when I adjust that, they will both adjust. Well, oh crap, I lost my paper that I wanted to show you. Okay, hopefully with some editing I can make that weird transition work. But anyway, so yeah, so the circuit, the potentiometer. Alright, so let me display something that was weird with this circuit. So here's the positive rail, and here's the negative rail. If we notice, they're definitely 17 volt, well, plus minus 17 volts, but there's a slight deviation there, about 300 millivolts actually, deviation, and something kind of weird keeps happening to the positive rail. But anyway, so here I will turn this knob, and we will notice that I went all the way down. Alright, so we notice our negative rail is at the lowest value it can go. It's 1.2 due to the internal reference of them two devices. And then this one is at 5 volts. And I'm like, well, what the heck? This should work. But then I noticed something that I've gotten to the data sheets, and I got the formulas for both these devices. And here I have it wrote out. It's kind of a mess, but so here is the negative formula. V out equals that 1.25 voltage reference and then the two resistor dividers, and then plus we can ignore this last part, so let's just focus on this part. So there's the negative one. If you look down here, this is the positive one. V out equals 1.25, and then it's okay, so they're the same. So what the heck? What's going on? But then I realized I have pretty much the application that the data sheet shows, the application circuit, and it shows for the lm337, the negative one, to put a 120 ohm resistor there between the output and adjust, and the positive one, it shows to put 240 ohms. Well, I'm like, well, duh, there's the problem right there. It's because the two ratios are different. Alright, so now I have placed both the same values of resistors between the output and the adjust pins of both regulators at 220 ohms. And now, if we see, both our rails are pretty close. I mean, you gotta realize this is a breadboard, and I'm using kind of a janky dual gang pot here, and them resistors are probably 1% tolerance of each other. So with all this in mind, let me slowly dial down the pot here. Notice our negative rail is starting to go down, and now the positive is following. And we see, I mean, like right here we're kind of off, but then we go to the full extreme bottom, and I mean that's pretty good. I mean, here we're 1.08 volts and then here we are 1.18, so I mean like 20 millivolts difference. So actually this circuit is working pretty good. Okay, so here is essentially the schematic. Actually it is the schematic for what I just demonstrated over there, our experiment here. So this is the gain potentiometer. They're just set up as a variable resistor, so I'm just using the 2 pins there, not using the third one there, but anyway. So what's wrong with this? So some of my design criteria, I want more stability, more stable, or yeah, whatever. And then I want a higher amperage output, especially for the positive. I mean, you can only sink like 1.5 amps with this device, and I would never go that high with just this linear regulator, and you would have to have quite a deal of cooling, definitely taking some thermal design into consideration, but yeah, so like, how could we improve on this? Well, one thing, this part here, so this is the adjust pin, so these are the adjust pins right here. This is the input, this is the output, and then our 220 ohm resistor here, and then our 10K dual gain pot. Well, instead of just putting the pot directly on there like that, what you could do, like what I'm going to have to figure out is, I'm probably going to have to use a buffer or a voltage follower, like an op amp, you know, just your standard voltage follower here, and then use the variable resistor there to input a voltage here, so it will insert into there. And then another thing is I want to be able to switch between tracking and non-tracking mode, so there'll have to be a switch of some sort, you know, just a switch or whatever. So I plan on kind of covering this whole thing in more videos, and I don't know who will see this or who even really cares, but yeah, just kind of want to try to teach some things along the way and kind of just cover it for my own sake, really.